All right, let's dive right into this explainer and kick off a seriously mind-bending journey to comprehend the true scale of the cosmos. Look, our universe is vast. I mean, it's so unbelievably huge that our human brains genuinely start to short circuit when we try to process the numbers outside our own solar system. But today, we're going to fix that. We're going to create a highly structured visual overview, comparing the absolute smallest objects to the most gargantuan structures known to science. By the time we wrap this up, I promise you're going to have a completely new perspective on exactly where you fit into this universe.
So what is the absolute largest thing out there? Well, to answer that, we can't just toss around numbers with millions of zeros. That doesn't mean anything to us. We need to anchor ourselves with something totally familiar, a physical scale we can actually picture in our heads, and then just continuously pull the camera back until our brains can barely handle the math. We're going to start with physical size, and by that I mean the actual diameter of these objects from top to bottom, not just how heavy they are. Okay, let's set our baseline. Imagine you grab the Earth and shrink it all the way down to a 12-centimeter ball, so roughly the size of a large grapefruit. On this exact same scale, our sun wouldn't just be a slightly bigger ball. It would tower over our grapefruit Earth like a 13-meter-tall school bus. You literally couldn't even fit the whole thing into a standard room. It is a massive, glowing sphere of plasma that completely dwarfs our home. But here's the kicker. In the grand scheme of things, our sun is just an average, medium-sized yellow dwarf. And this perfectly illustrates just how tiny our local neighborhood actually is. Because if we step just slightly outside our solar system, we run into Sirius A. This is the brightest star you can see in the night sky with the naked eye, and it's sitting a mere 8.6 light-years away. Compared to our school bus-sized sun, Sirius A is about 1.7 times larger, coming in at a massive 22 meters in diameter on our shrunken scale. It's a brilliant, luminous giant for sure, but honestly, it is barely scratching the surface of what the universe has hiding out there. Let's go ahead and skip right past those medium-sized giants, because we need to talk about the absolute monsters of the cosmos. Meet Stephenson 218. This is a red supergiant about 19,000 light-years away, and it is so unimaginably massive that if you somehow dropped it right where our sun is, its outer edge wouldn't just swallow up Mercury, Venus, Earth, and Mars. No, it would swallow Jupiter and push all the way past the orbit of Saturn. You could literally fit nearly 10 billion of our suns into the physical space that Stephenson 218 takes up. To put that into a perspective you can actually feel in your bones, imagine hopping into a normal commercial airplane. If you were flying at a standard cruising speed of 900 kilometers per hour, it would take you 1,500 years to complete just one single lap around the surface of Stephenson 218. Think about that. That is 15 centuries of nonstop flying just to circle one single star. So, what happens to our scale when we start talking about black holes? People often think black holes are incredibly dense but physically tiny. Well, definitely not Phoenix A star. This is currently the absolute largest known black hole in the universe. If we jump back to our scale, where the Earth is a 12-centimeter grapefruit, the event horizon of Phoenix A star would be a sphere roughly 5,500 kilometers across. Let that sink in. On a scale where our entire planet is a piece of fruit, this black hole is the physical size of the actual planet Mars. Phoenix A star contains the totally mind-bending mass of 100 billion suns. That's a 1 followed by 11 zeros. And what's absolutely fascinating here is that astrophysicists believe there literally hasn't been enough time since the dawn of the universe for a black hole to get this massive just by eating other stars. Instead, Phoenix A star is what they call a primordial black hole. That means it likely formed directly from the incredibly dense raw energy of the Big Bang itself, way before the first stars even flickered into existence. All right, so the crucial point here is that we basically have to break our scale entirely now. That 12-centimeter Earth model, yeah, it's totally useless at this point. We have to zoom way, way out and look at entire galaxies. Our own Milky Way is this beautiful, swirling city of 400 billion stars, stretching about 100,000 light-years from end to end. But let's compare that to the heavyweight champion of galaxies, IC 1101. Recent observations using some highly advanced light subtraction models measured IC 1101 at roughly 520 kiloparsecs, or nearly 1.7 million light-years across. That makes it roughly 17 times wider than our entire Milky Way. And to really wrap your head around the sheer scale of IC 1101, you have to look at its mass. Our Milky Way holds at most 1.5 trillion solar masses, and keep in mind that includes all of its invisible dark matter. But IC 1101? The stars of IC 1101 alone, without even factoring in a single ounce of dark matter, boast a staggering 3.4 trillion solar masses. It is an elliptical behemoth that completely redefines what a galaxy can even be. Okay, before we tackle the absolute largest connected structures in the universe, let's take a quick breather and look at the exact opposite, the Great Nothings. Specifically, we're talking about the Buit's Void. Discovered back in 1981, this is a spherical region of space that's nearly 200 million light-years across. Now, based on the standard distribution of matter, an area this incredibly massive should contain roughly 2,000 galaxies. You know how many the Buit's Void has? Just 60. It's a region of emptiness so vast and, honestly, so deeply unsettling that it remains one of the largest known voids in the visible universe. But as we zoom out past those individual galaxies and massive voids, we finally hit the cosmic web. And this brings us to Kipu. It's an incredibly huge structure located hundreds of millions of light-years from Earth. Kipu is essentially a twisted, branching rope of glowing galaxy clusters, and it looks strikingly like a giant cosmic nervous system. It stretches a mind-blowing 1.3 billion light-years across. Just try to picture 13,000 Milky Way galaxies linked end-to-end, like a massive glowing chain. And Kipu isn't just remarkably long, it is unbelievably dense. It holds the mass of 200 quadrillion suns. Just to be clear, that is a 2 followed by 17 zeros. Structures exactly like this show us that on the grandest scales imaginable, galaxies aren't just randomly scattered around in the dark. They're actually bound together by gravity into these massive, filament-like webs that form the very architecture of the cosmos itself. But hold on to your hats because, believe it or not, the universe gets even bigger. When astronomers map out the locations of gamma-ray bursts, which are literally the most energetic explosions in the universe, they reveal these absolute monsters hiding in the dark. We've got the huge large quasar group stretching 4 billion light-years and the giant GRB ring at 5.6 billion light-years. But the undisputed, though sometimes debated, heavyweight champion is the Hercules Corona Borealis Great Wall. Discovered in 2014, this grouping spans at least 10 billion light-years across. While some astronomers still debate if it's a single, gravitationally bound structure, the data clearly shows a clustering of matter on a scale that just entirely defies belief. And this right here is where we run into a massive, massive problem for modern astrophysics. According to a core tenet of physics known as the cosmological principle, the universe is supposed to look roughly uniform on these super large scales. Because of this, theoretical models calculate that structures larger than 1.2 billion light-years simply shouldn't have had enough time to form since the universe began. Yet formations like the 1.3 billion light-year Big Ring and that potentially 10 billion light-year Great Wall are sitting right there staring at us. They are literal cosmic conundrums that completely challenge our standard physics and how we think the universe evolved. Which brings us to the end of our journey today and leaves us with a truly staggering thought. We went from a 12-centimeter Earth to black holes the size of Mars, all the way to structures so impossibly huge they break the very mathematical rules we use to understand space. If our universe is currently hiding objects so massive that they technically shouldn't even be possible, it leaves us with one terrifying, but honestly incredibly exciting question to take away from all this. What else is out there? Waiting in the dark, ready to completely rewrite our understanding of reality. Keep looking up, because I promise you, the universe is always bigger than we think.